WolfSSL has been ported to a ridiculous amount of operating systems as well. I've seen them list a lot of platforms that WolfSSL has run on and has been ported to, but they have a different set. They have listed them differently, so they're not easily comparable, but they're certainly in the same ballpark, I would say. So WolfSSL runs on a similar set of platforms, I would say. Yes, Carl. So hello, everyone who's joining the Zoom right now. I'm just sitting here blabbing. I'm doing the same thing here on Twitch and on Zoom at the same time. So I'm talking to both at the same time. I'm just taking it a little bit slow to start with because I'm allowing everyone to join. The time is up, but I'm just letting everyone in a few minutes, have a drink, take a seat, and I will start the presentation in a minute or two. So just find a comfortable position in your chair, maybe get a drink. I actually forgot to fill my glass here with water, so I will just skip it and maybe fill it later in case I sort of run in, if I can't endure it without. So give this another minute and I will start it. This is a session that is going to last for maybe around 2 hours or so. I don't quite know exactly how long we're going to do it, how much time it'll take. But if you feel that you have to drop out before it ends, of course, do that. Of course, I will make them both parts. This is the first part and the second one on Monday, but both will be available on YouTube after the fact as well, in case you nod off or just have to go and eat instead of watching this, or who knows, maybe work. But okay, I think we are getting ready for this, and I'm going to get into that when I start the presentation for real as well. But I'm going to try to address questions both in the chat and in the Zoom, and I'm going to try to repeat questions that people are asking in Zoom so that it'll get recorded properly and gets streamed on Twitch at the same time. So it's a little bit complicated setup, but I'm sure we can work it out. So if you have any questions, feel free to type them in, maybe in the chat, ideally. To in the Zoom, you can do that in the Q&A question thing. In Twitch, you can just enter the question in the chat, and I will try to get to them maybe at some suitable point in time. I think it might work best if we try to address the questions in the middle of everything, because otherwise I fear that I will just move on to something completely different if we don't hit pause and take the questions immediately when you have them, or fire them off afterwards and we can just get back to that. Whatever works for you, and you can always contact me or us after the session as well, in case you have things you think about afterwards or whatever. So I want to start the presentation now. So let's go. Welcome, everyone. This is Mastering libcurl Part 1. Yes, so let's start this. I am, of course, Daniel Stenberg. I am the lead developer of the curl project. I've been doing this for a long time. I'm available on the socials, like in Mastodon, as you can see my account there. I work for WolfSSL. We do curl support. That's in case you want help or have anything related to curl that you and your business want us to help you with. We are here today. Or this mastering libcurl setup is basically done like this. So it's a 2-part session. I'm going to do the part 1 today and the second part on November 20. That is on Monday if you're doing this live. So it's going to be it is live streamed, and you can see it in both Zoom and on Twitch at the same time, whatever you want. And it's expected to last multiple hours. I'm hoping that I will go for about 2 hours apart. So 4 hours in total, maybe a little more. They are both going to be recorded. They are both going to be provided after the fact, of course, in case you miss any parts, want to go back, or have to leave early. There are going to be lots of material you've never seen before. I haven't talked about them before, so there's a lot of new slides that I've done. So bear with me. I'm sure I've done several mistakes, but I'm sure we can get through that. And there will be a lot of source code on display in these slides here. So make sure that you can actually read text, at least this size, maybe a little bit smaller as well when I get to them, because showing source code on the screen, you probably need to be at least decently sized. Otherwise, if you don't see the source code and you want to go back and see the code in detail, this URL here, the last line here, is a dedicated Git repository. You can go, and all the examples that I will show in both part 1 and part 2, they are available there. In ready to compile versions, they actually sometimes contain a few more lines that I will show on screen, because they include stuff and things like that. So make sure that they actually build them, and they should work. And that is a Git repository. So if you find errors, you can submit an issue or pull request or whatever. So if you want to base something on something I explain, go there and copy and paste from those. A convenient thing. So, and again, ask questions if you have any, either just immediately in the chat or in the Q&A thing in that Zoom, and I will try to get them as I speak and explain to you today how things work. Since it's a pretty long thing, it might be a little bit too long to wait to the end for the questions, because then we might have forgot what we actually were talking about, a long time ago. So let's hit it. This is what I'm going to talk about. So this is part 1, November 16. That's today that I'm doing this recording. So I'm going to start talk about the project, remind everyone how it works, where we are, then how to get libcurl, stuff about the ABI and API, how the main architecture of the library, some fundamentals, how the API and the APIs work, setting up your connections when you want to do a libcurl transfer. And that is basically where we are going to end. That's the intermission. And the next part, that's kind of amazing, right? Those 6 bullets are going to take a while to get through, but there's a lot of material you'll see. And then the next part, that is going to be equally long, possibly slightly longer than, I'm going to talk about more about how controlling different aspects of the transfers that you set up, how the share API works and is it designed, a lot about tweaking things for TLS, how to do proxies, and a lot of these are then dedicated to particular options that you can set to control transfers with these properties or functions. And the header API, the URL API, very briefly about WebSocket, because I've done this completely separate session before. So if you want to learn about WebSocket API, you better go and see my dedicated WebSocket stream instead. That's basically, I think, 45 minutes, just WebSocket API discussion. And a brief thing about the future of libcurl and where we might go next. So that's the second part, but the second part is, of course, not today. So let's get into it. This is the project we call curl, right? And it started out in the early 1996, actually in the late 1996, when a developer, not me, released a project called HTTP GET that I found, started playing with, submitted patches to. I became the maintainer of, and in August 1997, I had renamed it and I called it URL GET because it could support more than HTTP by then. It became curl in March 1998, the command line the project and the command line tool, and then actually in August 2000. We presented, published, released libcurl, the library. So, and we have always released them together in the same tarball. So you typically you build both the command line tool and the library at the same time. But that journey started, the libcurl journey started in August 2000, when I just wanted to convert and provide the internet transfer capabilities of the command line tool to other applications, other users who might want it built in to their applications, right? So that is how we all started. And curl, of course, the name, it comes from C. The C is not the language C, as a lot of people would insist, but it's for client. I wanted it to be a short name. It should be possible to type in a command line because of the command line tool. And I also appreciated that you could possibly think of it as a C, a URL, or the contents of a URL. And afterwards, we figured out fun things that it could have been curl URL request library or just capable, ubiquitous, reliable Libre. But it's just a name. This is the project, the tool, and really the main products we have in this project. Of course, the project is called curl. One of the main products is the command line tool that we call curl, and we call the library libcurl. Sometimes, and I'm guilty of this myself, I also refer to the library as curl. So maybe sometimes curl is the project, the tool, or the library, or all of them, or sort of a few of them. And it's curl. Curl, the library and the command line tool is always and only client-side transfers, never a server implementation. We pretty much draw the line there. And it's always transfer related, upload, download, or both, and it's associated with an endpoint that is a URL. Either you upload to a URL, or you download from a URL. It is completely and has always been open source. Everything in curl is open source, and everything is done in the open. So we try to do everything as transparently and as open and available as possible, so everyone can join in and participate wherever and whenever you want. And you can reshare and change anything. The curl license is what I call essentially MIT license, because it's slightly modified, but it's slightly modified in a way that shouldn't actually affect anyone. So I actually call it MIT licensed all the time, even though it's, strictly speaking, not exactly. This is the curl license. All the language should be familiar to anyone who's read an MIT or BSD style license, because it's basically the same. In the curl project, everything is developed what I call by everyone, because everyone can provide code, participate, and help out to your abilities and what you want and needs and so on. I'm the only one who's involved in this that I know of, who works on this full time. But to participate and to provide anything, you just have to submit a pull request. You don't need to do any kind of agreements or sign papers or anything. You can just get there, submit it, and we will review, provide feedback, and then we will make sure that it is good enough before we merge it. And of course, it's thoroughly tested and proven before we merge as well. And there's a small team of maintainers other than me that can accept and merge changes. I think we're actually around maybe 15, 20 people who have the powers to do it. So it could be a set of other people beside me. And that team of people is, of course, also sort of changing gradually over time. People are coming and going as usual and to be expected. So we do releases every 8 weeks. Typically, that's what we aim for. Sometimes we do them sooner when we have a nasty bug that we want to make sure that people don't have to suffer from longer than necessary, and then we do them earlier. But the plan is always to stick to the 8-week release schedule on Wednesdays, 8 weeks, Wednesdays. So we're right now at 252 releases since that very first HTTP GET release that I didn't do, counting all until today. Then, and we so the releases are always time-based, right? So we release what is in the master branch at the time of the release. So we don't do many very crazy separate development branches. So we stick to the master branch. We make sure that the master branch is always working, and it should work. And by the time the release date is here, we just ship what's there. well, we tag it and so on, but that's how we work. And we have this 8-week release cycle. So pretty much it starts here on the right side, which is the release Wednesday, and then we go down. We have a 10-day cooldown period after release. If nothing serious was reported during those 10 days, we open the feature window, and we have a green feature window for 21 days. That's 3 weeks up, and we're coming up to that Saturday up when the green turns red. And then we switch off the feature window, and we go into a feature freeze instead, and we have a 25 days feature freeze during which we only allow bug fixes to get merged and no features or changes, or what we call. So, and then after that 25-day feature freeze, we have a release Wednesday again. So on and on and on. So this is the eternal 56-day, 8-week release cycle that we stick to, unless we have to do an early release. And one of our fundamental cornerstones in the project is, of course, that we never break existing functionality. Things that we have implemented and shipped, we stick to that. We hold on to our promises. So whatever we ship, you started to use it, you should be able to rely on the fact that we will not break it, not willingly at least. So sometimes, of course, we have bugs, but then we fix the bugs and we ship again. We do everything on GitHub, pretty much, you submit your problems as issues, you propose changes as pull requests. As you know, these days, more or less a classic GitHub development model. This is the GitHub URL. You can go there, github.com/curl/curl, curl project, the curl repository in the curl project. If you want to read up on more things on how to learn this, if you don't want to listen to me blab about it, you can go, and we have man pages for everything. We have everything, all the man pages and all the documentation is also provided online on this website, right? curl.se/libcurl for all the library stuff. The book, Everything Curl, the image here is the cover. It also contains a lot of descriptions and tutorial stuff about how to program with libcurl. If you don't find the answers to your problems, your questions, you can ask for help, and we have a mailing list that is active, and you can go there if you have any library development using debugging, blah blah, whatever, and it's related to libcurl. It's the curl library mailing list. You go to this URL to subscribe, and then fire off. And you can, of course, ask about anything that is related to curl and curl development, libcurl use protocols, things like that. And if you prefer to not use a mailing list, you can go to the sort of web thing, the web discussion thing on GitHub on this URL. If you go to the curl repository, and there's a discussion link at the top, you can go there and ask questions or similar things. And if you want to pay for help, if you're a commercial entity, you want to get some professionals to help you out really soon, maybe this afternoon, you get in touch with us at WolfSSL, and we can help you immediately. So anyway, curl supports a lot of stuff. The amount of features is actually kind of astounding and mind-boggling, but yes, but in spite of that, or maybe in spite, but in addition to that, it also runs on pretty much everything. So whatever you use today or tomorrow, you used last year, or you're going to transition to in the future, you can be fairly sure and certain that curl and libcurl will run on whatever you throw at it. And I actually recently did an update to my collection of operating systems that curl has been proven to run on, and we are now at 101 operating systems that people have reported has been able to run curl or libcurl or both. So it's an amazing number of operating systems. Of course, most people cannot even mention more than this very small subset of these operating systems. I know I certainly can't. But it's a hobby of mine to collect these operating systems anyway. So it's this is of course done by a lot of people. So we recently crossed the line there. As you can see on the right side here, the number of commit authors surpassed 1,200 recently. I think we're 1,217 or something right now. Most people, of course, that's the green line here, are single committers. Only roughly 60-something% of all the committers only committed once, but that's fine. An improvement is an improvement. So anyway, as you can see, a lot of people are providing code, and a lot of people, many more, are helping out in different ways. Submitting bug reports, helping out with infrastructure, just advising on how to do things, or providing good ideas and things like that. So, and we keep track of everyone who's helping out, and we are saying thanks, and we give them credit for whatever they do. And that list of contributors have recently surpassed 3,000. And people, when I show this graph, it's inevitable that that people are asking about the bump in the year 2005. Because why is that such a break in the graph there? And the boring fact is that's just because at that year I went back and added all the names who had ever helped out, so sort of corrected past mistakes. So it shouldn't have been a bump. It should have been higher gradually before that. But hey, I do my best. And the number of lines of code in the project has been gradually increasing, of course, ever since the beginning. We are at around 160,000 lines of code right now in everything in total, if we include comments, excluding blank lines, actually. So you can see that we are constantly adding a lot of code, and it's a strangely linear growth as well, right? Anyway, that means that we are today counting at somewhere around 20 billion installations. And it's an open source project. People are installing this without telling us, and we certainly don't know in how many units everyone's installs are actually running. So this is a very rough guesstimate. Maybe it's 10, maybe it's 40, who knows? And it's also, of course, constantly changing. So it's impossible for us to actually have a very detailed number. And of course, all these users or all these installations, they are using it in this way. So all of these different devices here around the cloud, games, fridges, loudspeakers, cars, TVs, cameras, printers, kitchen devices, phones, tablets, video doorbells, and game devices, watches, medical devices. All of these things are talking to other things on the internet, right? Most of them are connecting to a server somewhere. They want to do some download, upload, do stuff, figure things out. And today they all often go to using curl for that, right? So all of these use curl as the little component, libcurl as the little component to communicate with their particular servers and to do their transfers. So when you want to work with libcurl, you of course have to first get it, right? And in most cases, you just install it. So if you're running a Linux distribution, or you use a BSD, or even if you run like things on a Mac, Homebrew, or Mac ports, things like that, or on Windows, you can use this VC package, Chocolately, complicated name to pronounce, or Conant, 3 different ways that are sort of a package manager on Windows managers. Or, I mean, of course, every system has a lot of different alternatives and options, but I wanted to just say that there are options for all of them. And at this screen, I'm just showing you a set of different ways how you get libcurl installed on your system. Like different Linux distros, different BSDs, different Mac approaches, and different Windows approaches. All of these different things here, just showing different command lines here, how you install those packages to get libcurl, the libcurl development package installed on your system, because you want the libcurl development package installed so that you can develop your stuff using it. Or, I mean, of course, a perfectly fine option is also to just build it yourself. And then you have a few different ways to build it yourself as well, because why have it one way when you can have many different ways? So the classic way is, of course, if you're using Linux or a Unix thing, you can do it with configure or CMake, just the classic styles, how you use them normally. Or if you're using Windows, you can do build with the Microsoft Visual Studio thing. And if you do build libcurl yourself, you also want to use third-party libraries really to support stuff that curl needs. And when you do that, you want to make sure that you install the development versions of these third-party libraries so that you can get that stuff working properly when you build libcurl. And here's our two, I'm just showing you here how to run configure, and this particular configure line then shows how to enable it with OpenSSL. And you just make and then make install, and with CMake you do a similar thing. Actually, the CMake line there probably needs to say that it needs OpenSSL as well. I forgot about it. But that's the way you do it. And of course, if you want to do it Windows style, you can either build with the nmake, which is wrong. It's a typo there on the slide. So you can build from the command line with the Visual Studio, or you can build with the Visual Studio project files that we ship. In all curl releases, we actually generate those kind of project files, so you can load it in your IDE and build from within Visual Studio if you want to. And similarly, you can build curl pretty much on all systems like this. These are just convenient provided ways, but building it in other ways is also possible. When you build libcurl yourself, instead of installing it from somewhere, you have the opportunity and option to customize it, right? Then you can enable, disable particular features, protocols, and select third-party options. And then if you do that, you should just remember that the libcurl API, it's the same thing, right? It's always the same, but depending on what you enable, disable in your build, they may then return differently, right? If you disable a certain protocol, then trying to use that protocol will, of course, return an error because you disabled it. And of course, this is a very popular way. If you, all those, I showed you those images of different things that are using libcurl, they are typically built libcurl themselves, so you can remove things you won't use or use the particular third-party libraries that you like to use, so that you have you control the environment, you control better exactly what you ship in your stuff. And when you use third-party dependencies, and you really want to do that in curl, because with libcurl, it doesn't implement all the details itself, but relies on other quality third-party libraries to do certain parts that are necessary to do to perform a network transfer. For example, TLS. If you want to do HTTPS transfers, you need TLS, but curl itself doesn't implement TLS. It uses a third-party library. TLS, SSH, LDAP, RTMP, or a compression thing with HTTP, even just the binary HTTP2 level transfers and HTTP3, including the quick part. And even if you want to do asynchronous name resolving without threads, like using CARES instead, or several auth options, you need a third-party library that helps curl use them. Typically, when you install from somewhere and you just install libcurl dev, someone has built that libcurl for you with a particular set of third-party dependencies, and then you just get all of them automatically without you having to think about it. And the requirements on libcurl, they are not very high or complicated. Pretty much, when you build libcurl, it of course gets it ends up with a certain size, right? After a link, and bam, you get a library. And the most minimal libcurl build with the smallest TLS, it's around 100K on disk. I say 100K. It depends on what architecture as well, of course. But on a 32-bit, it's around 100K if you have a really stripped down TLS as well. So that's the lowest possible end, pretty much. And the lowest possible memory requirements for libcurl itself is around 20 kilobytes. It's a very limited. You usually spend more than that. And I should also add that even if I say 20 kilobytes, that's for libcurl itself. Usually the TLS part also uses actually usually more than that to be able to function properly. So yes, that's what I mentioned. It adds more memory requirements for the TLS library. But what is important to remember then, of course, is that even if you build the most stripped down libcurl, it still has the same API. Of course, most features, if you go with the smallest one, you have disabled a lot of features. So a lot of function calls will return not implemented, but you can still link it with it as well. So you have installed it or built it, then you have to use it, right? So libcurl provides an ABI and an API and an ABI. So first, I wanted to just mention that it is the same API on all platforms, which means that if you're writing an application that is using libcurl, the libcurl using part can be the same on whatever platform you don't. So it's also easy for you to make your application portable as long as you're using libcurl, because libcurl could work as that portability layer. And you can always upgrade to the next version of libcurl without breakage. That's the promise we have. So that's what I alluded to earlier also, and I will probably repeat this, that we don't break existing behavior. It's compatible. But you may not be able to downgrade, right? If you start implementing features that were introduced in this version, you can't go back to the previous version, because of course that version didn't have the feature it has now. And that's also one of the reasons why all the options and functions are clearly documented, sort of in which libcurl version they were introduced. So you know, blah, blah, blah was introduced in version this. So you know that that's the lowest possible version that you can use for using that particular feature. And we have done a lot of versions, right? The first libcurl version shipped in August 2000 called 7.1. And the most recent one at the time of this recording is 8.4.0. We released it on October 11, 2023. A little over 23 years later. We have bumped the major version number once. But yes, there are basically 200 releases in between those different ones. They all differ in features, in protocol support, in performance, in behavior sometimes. I mean, not behavior as in the ABI behavior, but in behavior over the network, because sometimes we have figured out and adapted things to work better, smoother, more compatible, or sort of stuff like that. And of course, more later versions, newer versions have more functions. We add functions over time. I showed you the number of lines of code. Part of that is because we add features. Not only because we add features, but we also pretty much just improve code, right? Make it more tolerant, work better, more secure, and stuff like that. The libcurl API we work with is for C, and that's what I'm going to talk to you about today. And I'm going to show you numerous examples later, and they're all going to be written in C. And of course, you can use it for C++ as well, because C++ is basically C with the cherry on top. But that's more of a coincidence. We're sticking to C, and what's a good part. Most bindings that are provided by people for other languages, and there are many. I think we count more than 60 bindings these days that people have written to offer libcurl powers to other languages. Most of those bindings are rather shallow and thin layers between libcurl and that language, and they often provide more or less the same kind of API. So you can often, by reading and understanding the C API, you can often use that knowledge and just translate it over to your other language without too much trouble. So I will speak C today, and I will show you a lot of examples, and I will, all examples that I show also have names. which is good for you if you go back to that Git repository and you want to check out the example after the fact. Just remember the name of the example, and you can find it there. Yes, and what is sort of we have gotten around to, this didn't really start out like this, but whatever you do when you use libcurl in your application, you just need one header file, and it's called curl/curl.h. This is the only include file you need to get all the curl stuff you want in your program. Of course, you might want to need other include files for other purposes, but for curl stuff, you just need this header. Easy peasy. In most of my examples, I have actually just not included the include file, so you won't see the include file that often. But in the examples that in the Git repository, they have includes. And when you have started to write your application, you want to link with your libcurl library. It's easy. If you run it with a typical GCC or Clang, you just build your code, link with libcurl. Usually, when you have installed it with your Linux distro or something, they have installed the libcurl in a default place, so you don't have to tell anyone where it is. It's in a system default library directory. So these are perfectly fine ways to just build your libcurl using source code. But as long as you build with whatever you build with, just somewhere you tell your compiler where are the curl header files and where is the libcurl library and how to link with that. And then you can build with whatever C compiler you want. It's not very complicated. As if you've never done C programming before, it might be a little bit of an uphill battle. But if you just learn your C basic stuff, and then you will learn how to link with other libraries, and then you will link with curl just as well as any other library. It's not more complicated than that. And when it comes to documentation, we document a lot of things in detail for everything. So every function and every option has man pages, their own dedicated man pages. So I think we are up to almost 500 individual man pages. We have more than 120 standalone examples in the Git repository for curl. I mean, excluding all the examples that I will show today. Some of them are pretty similar, of course. And if you go to the website at curl.se, the website always has all the man pages, the latest version of them always rendered online, and it always has the latest versions and the latest collection of all the standalone examples as well. So if you go there, you can find the latest editions of all of them. And of course, again, I mentioned it already, everything curl, the book, it provides even more resources. It will go into describing things sometimes a little bit different from and more of a tutorial style than maybe the man pages do. And what is good here is that it is actually pretty easy. So if you just have a function name or an option name with libcurl and you're thinking, how do I use this? Just Google it. I'm sure our documentation is usually the top link, or at least one of the in one of the top results. So it's easy to find the documentation for whatever option and function you want to use. So getting into this, and I hope you're getting warmed up. So I'm actually already half through, and we're only 35 minutes in. So I'm going to be able to spend some time to explain all of this to you. So the libcurl architecture, this might sound complicated, but I'm just going to be brief and talk to you a little bit about some general design ideas we have in the project. I'm not going to explain exactly how everything works because that would be unnecessary. So I wanted to go back to the fact that the API, the curl API, libcurl API is for C, right? And we have written everything in libcurl in the language C, and the flavor is called C89, sometimes C90. But and I just wanted to emphasize that we do this. We still have everything written in C89 in libcurl. And when we started this journey, there really was no other alternative that was a serious option. So we started with it because that was the sensible option. And maybe now there are alternatives. And I'm saying maybe because I'm still not convinced that there are actually quality alternatives to write system level libraries for a wide variety of operating systems. But let's say there is, but we started this and we've been doing this for quite a while now. So the fact that it is written in C makes it extremely portable, right? The explanation that the fact that it runs on 101 operating systems at least, that is to a great deal explained by the fact that it is written in C. So yes, it is not a memory safe language. We might get a certain amount of problems because of this that we could have solved by using another language, but by sticking to C, we also have this extreme portability and existing everywhere sort of chance. So the plan is to maybe over time allow different portions and pieces of curl to be written in other languages, and we can sort of select to use that at build time. But I'm also convinced, and I'm going to sort of stick to this, that the C code version of all those alternatives will also remain a build option to remain this portable as, run everywhere option. libcurl is a core. It is sort of built up around a core with a lot of different backends for different protocol options. And that's what I'm going to show you. So basically, there's this yellow application that uses a public API to get into curl, right? That's the public API has, I think, around 90 different function calls you can use to do transfers. And you have a public API, and that API, it has it's a defined way to work. You can read the documentation, it works the same way. You can upgrade curl, it works the same. But to power libcurl itself, for example, to do different protocol-y things, it has a large set of internal APIs. You won't see them from the outside, but they exist in the inside. And when curl are using them, they can themselves get powered by a number of different backends. For example, if you want to do content encoding, which is pretty much a fancy way to do HTTP compression, different compressions, like this set of examples here in the little box: zlib, brotli, zstandard. 3 different ways to do HTTP compression. So if you want to do transfers with one of those compression methods, you have to support, curl has to be built to support one of those libraries. And then so we have a backend for different content encoding, codings basically. And you can have 0, 1, or 2, or 3 of them supported in your build. So basically you select that set at build time. And if you want to, for example, every time you want to do transfer using a host name, you want your curl to resolve that host name into an IP address. And to do that, you need to have curl. When you build curl, you tell curl which kind of resolver solution you want it to use. You can use a synchronous resolver, the threaded resolver, or the CA-RES resolver. So you have to pick one out of those 3, and you have to use one because otherwise it won't work. But of course, again, from the outside, from the application, the yellow cloud here, it doesn't know, and it doesn't have to know, it doesn't have to care. Well, sometimes it needs to care, but the idea here is that it's transparently not shown to the outside world. If you want to do international domain names, right, IDN, you can select to build curl with one of the 2 different IDN libraries that we support, either libidn2 or the WinIDN, which is the Windows native one. And you get the picture here. If you want to build curl to support SSH, which in curl means SCP or SFTP transfers, you want to build curl to and use one of these different SSH libraries, the libSSH, libSSH2, or wolfSSH. So therefore, from your application point of view, when you want to do an SFTP transfer, your application doesn't know, but curl then could use different backends to do that particular transfer. And the same goes for HTTP. If you want to do HTTP2, for example, you could go with the built-in NGHTTP2 solution or use Hyper. If you want to go with HTTP3, you have 3 different solutions to go from. And if you're then using TLS, like in HTTPS or some other TLS-based protocol, you know, IMAP-S or POP3S or FTPS. There are a lot of TLS transfer protocols, and if you go there, you have 12 different backends to pick and choose from when you build curl. So all of this, and just saying you that sort of curl is that core with a lot of different backends that could be different and that are selected at build time. Usually it's totally opaque. You don't have to care about it. It's supposed to not interfere with you, but sometimes they will, and then it's good for you to know that this is actually how it actually works under the hood. And another thing is that everything in curl is non-blocking. And I say everything with a little asterisk because there are a few rare exceptions, but we don't talk about the exceptions here. Everything is non-blocking. So it means that it can do parallel name resolves, you know, a lot of name resolving at the same time. It can do a lot of parallel connection establishments at the same time. It can do a lot of parallel TLS handshakes at the same time. And of course, it can do parallel transfers. All of this with different latencies, different bandwidth to different hosts over different connections, you know, near a server near you, a server very remote from you. And all of this, it does in a single thread. So when you use libcurl, everything is in the single thread. It's never another thread, so you don't have to care about other threads. You really shouldn't care about other threads when you talk about curl. The API works in this thread. It won't start another thread. Well, it might start another thread in the background, but you won't need to care about it, but because you will interfere with it in a single thread. I will get back to threading, I think, in part 2 and talk about it a little bit more. So that's a little bit of the design ideas, the architecture stuff. So now let's get started with the API things. So finally, 40 minutes in, we're going to talk about how to actually interfere with libcurl. I want to just say a few things to remember when talking about libcurl that will repeatedly come up. And, you know, I view it as a sort of the 3 sides of the pyramid of libcurl, maybe. Or maybe it was just an effort for me to make anything to fit the pattern of a pyramid. So it's that all handles, there are a lot of handles, and I'll detail a lot of handles. They're all opaque, which means that you cannot access any. They're just pointers into something, and then you need functions to use something out of those handles. But we have a standard approach to handles, and you will recognize that soon. We always talk about URLs as an endpoint to transfers. URLs, without a URL, you can't do any transfer with curl. It's the only mandatory option when doing a transfer. You need a URL. And it's very callback focused. So data is usually provided and provided to you, and you provide data with callbacks. And not only data, a lot of different activities and actions are callback based. And I will talk about a bunch of the callbacks. Maybe not too many today, but in part 2 there will be more. But it's fun. We'll get to at least some basic callbacks very soon. So libcurl internet transfers. So let's do a transfer. libcurl does basic transfers by default. This is a sort of a primary setup for libcurl. It is basic by default. So if you want to do a libcurl transfer, you can just know that it won't be very fancy by default. It will do the bare minimum, right? You don't add. So when we add things, usually they are opt-in options. So if you want to do more fancy things, you have to switch it on, right? Enable all the bells. Without any enabling, it'll be just no bells. And the API is also largely protocol agnostic. That means that you're usually just talking about a URL, and without an application as you write it, you don't have to know a lot about protocols or understanding a lot about protocol implementation or details or even networking. Usually just give libcurl a URL and it'll do the transfers with it. You change behavior from that basic one by setting options. So, and you will see, and you will, I'm going to talk a lot about options. So options is really it's driving libcurl. And to get started with a application that is going to use libcurl, you need to do a global init. That's what you should do for several reasons, but there basically a chance for libcurl to set things up that are meant to be set up just once and never again until you're completely done and you're about to die. So you have the complete reverse too. So you have an init and you have a cleanup. It works like this. The first source code, global.c. And here I've just decided to grade out the non-important parts because it's a global init first. It just says global default. And there's a global cleanup, curl global cleanup in the end. So an init, do whatever you want to do with libcurl, and there's a global cleanup. In the past, it has been more important than before because in the past we different, depending on what kind of operating system you're on and so on, we might need to init TLS libraries or socket things or things like that before libcurl can be used. And if you don't call global init yourself, libcurl will actually do it behind your back and sort of second guess what you want to do. So it might still work without global init and global cleanup, or usually it actually works, but we encourage you to use a dedicated and explicit init and cleanup to make it clear and avoid mistakes just because maybe libcurl didn't guess it correctly otherwise. So what you want to do, a transfer. Obviously, you want to do an internet transfer because that's why you're using libcurl. So you want to do a transfer because it's transfer oriented. We do transfers, and then you set up an easy handle. We call it an easy handle, curl asterisk handle. That's a pointer to a curl handle. We also often call it easy handle because it's the easy interface. I actually called it easy interface as it was the first API I designed for libcurl, and I wanted it to be easy. So let's call it easy. And I wanted to have the more complicated later. And then they were not, the more complicated one is not called complicated or difficult or hard. But anyway, this is the easy interface. Then this, as again, I mentioned previously, this is an opaque handle. It's just a handle, just like a file pointer. When you do a regular C programming, you know, when you open a file, you can get that file pointer back. It's just a pointer. It's a handle to something. And a curl handle like this, an easy handle, is just a handle to an internet transfer or potential internet transfer. And it's a single one, even if this single one can be done over and over, but it's a one handle to one transfer. And we encourage users to reuse this handle to do more than one transfer because it also has a lot of caching and saving things. So if you reuse it, it might actually do the second transfer faster than it did the first transfer. And you get such a handle with this curl easy init and in easy handle and return it. Bam. And then when you're done with that easy handle, when you want to shut it down, close it, free all the resources, you would call curl easy cleanup. And you will see this pattern in more occasions soon, the init and the cleanup. So the init one returns a handle, the cleanup one kills the handle. So pretty much like this. First, you do an easy init, you get the handle back, and grayed out here, you can see that it's actually using that handle. But when you're done using the handle, you clean up the handle, and voila, you're done. That little part in between the easy and the cleanup is, of course, what is actually, that's actually the performing something, right? Doing the transfer. And to do a transfer, you have to set a few options. I already said that you need to set a URL at least, right? So you create a handle, and then you set a lot of options telling libcurl what to do. You want to do a transfer, but what kind of transfer? What do you want the transfer to do? How to do it? So the options you set are sticky. And with that, I mean that once you've set it, it will remain set in the handle, right? If you set verbose, enable verbose, it'll be there until you change it again. Even if you reuse the handle, it will remain set. And if you set more than, you can set different options. There are many options. I will come back to that as well. But they are independent typically. So you can decide to set a few options on, a few options off, or on, off, or blah, blah, blah. They're usually completely independent. So if, a lot of options and they're all independent. So you can imagine that the amount of combinations are really crazy. And they're also then order independent. So it doesn't matter if you first set the verbose and then the URL, or the URL first and then verbose, or when you add a number of options, it doesn't matter in which order you set them because they're independent. So you just set them. Make sure that you set the options you want to set in whatever order you think is fine. And if you set strings, they copy the data. So if you set a URL, the libcurl will copy that URL into its own memory. So you don't have to keep the memory around after you have passed it on to curl. And as I said, the only mandatory option, the only thing that you have to set for a transfer is the URL. Because otherwise, if it doesn't have a URL, it doesn't know how to do the transfer, right? The URL is the endpoint in the other end. It needs the other end. The local end is you here when you're running the application. The other end is identified by the URL. And if you don't set any other option, download is the default action. So it will try to download that URL if you just set the URL. A typical application will set many options, possibly, 5, possibly 25, but there are a humongous amount of options. So you can control, change, set pretty much anything related to this transfer. As I mentioned here, timeouts, resolve things, connectivity details, protocol versions, TLS details and versions, authentication, a lot of that. Proxies opens up a whole slew of new options, and then decide exactly how to retrieve and send the data and how to behave in different kind of situations that might appear. So depending on your needs, you might get a lot of options to set, or maybe you don't have a lot of needs, and you might get around with just setting a few. But I just wanted to throw this at you. So yes, over 300 options are available to set. They're all also in a flat hierarchy. So there's no tree or anything. It's just a long list, 300 names that affects different parts of the transfer. But of course, so basically, if you want to do something, you need to search the documentation or figure out exactly what option to use, or if there's an option to use for that particular thing. And you set options with this fine function called curl easy setup. It sets an option in an easy handle, curl easy setup. It works like this. There's the first argument, it returns a curl code. The first argument to the function is the handle that you want to change or set an option for. The second argument is the option, and that is a curl opt underscore blah 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 name. And then it's the third option is the parameter for that option. They are always 3 arguments, but the third argument here could be a different type of argument depending on the option. And that is a little bit of a complication. And if there ever is something I may regret when I decided this API is this choice, but too late. We're already on this journey now. So it does this by doing this C thing called var args, which pretty much means that the compiler cannot really check the type of that third argument. So you need to make sure that you provide the right type in the third argument, because the compiler might not tell you when you're doing it wrong. You might then get a runtime crash instead, which is really boring. You might want extra type costs there, so they make sure that you provide that argument with the correct type, so that libcurl understands the option that you provide. And again, when you set strings, libcurl will copy the data, and it will return an error code, of course. If something failed, set this option. Did it work? Did it not work? It works like this. So I sort of, again here, this particular little example here, it sets first, the first setup is the URL, https://curl.se/, and it is then setting the verbose mode to 1. And so see here, it uses 1 capital L. That means that it forces this to be a long type. I will get to, I got a question about if there's anything, if there's a blocking call using curl and how to determine the error. But I will get into blocking calls and how to do the transfers using blocking calls and not blocking calls. So hang on for that. There's also a question about caching, but I will get back to a lot of caching too, and about doing things or speed, sort of using sort of transfer performance and doing things faster with curl. I will get back to that as well, because that's a common thing to ask about. So just hang on and I will get to it. Where am I? So like that, you create the handle, you set a bunch of options, the URL one and a few other ones, and then you do the transfer. And here the curl is a perform. It performs the transfer using the easy handle, and curl is a perform is for synchronous transfers. It's a blocking call. I told you before that everything is non-blocking, but that's not. It's non-blocking internally, but this is an API that is a blocking call. It will do the entire transfer and then return. So possibly, if the transfer is really slow or is a really big file and the server is really slow, it could be hours, right, before it returns, or it could be milliseconds, depending on which kind of transfer you do and to which server and which protocol and so on. So it performs the entire transfer to the end, and to the end here is either it's successful or until it fails, and then it returns. And the failure here is, of course, also sort of reaching a timeout. If you set a timeout, so try to do it within this many seconds, and until if it doesn't complete within that amount of time, it will return a failure and say, hey, I timed out. But normally, of course, curl is a perform will do the transfer as fast as it just possibly can, which means there's no artificial waiting anywhere or slowing down or throttling anything by default. It will just run as fast as it can. Typically, when you do a network transfer, though, it's often the network itself that is the sort of bottleneck, or the network interface or something, the connection to the other side. It's very rarely that libcurl itself is the blocking or the limitation here, unless you download something from yourself or whatever. But that's more of a rare setup. So it might take a very long time, short time, medium time. It's hard to say. You can limit how long time you want to allow it to spend before it fails. And it returns an error code. And if it's 0, it's okay. If it's a non-zero value, it's an error. And there's a lot of cached info that is stored in the easy handle. So in the easy handle, when you do a transfer, it not only does the transfer, but it also stores a lot of meta information about the transfer, and it also has caches related to the transfer. That's also the caching. I will get back to the caching. Forget about it for just now. So I just wanted then to go back and highlight the example here. This is how it does the curl easy perform, right? Create the easy handle, set options, and in this case, in this example here, only one option, just the URL, and it's a download by default. bam, curl easy perform. It will download the contents of that URL by default. And since we don't have any other options set, this will just throw out the output on standard out, which admittedly is not usually what you want your application to do. So this is a bit simplified. Maybe you don't want this your application to be this simple. But still, that's how you do it. And once you've done your transfer, maybe you do another transfer, reusing the same easy handle, or another. You can do any amount of transfers reusing the same handle. You just set a new URL and you go. But when you're done with it, you kill it, and you kill it with curl easy cleanup, and it kills the handle and frees up all the resources that are associated with the handle, caches, data, blah, blah, whatever you have internally. Gone. And of course, then there's no memory leak or anything. But you might also just want to do curl easy reset. The curl easy reset function is a way to just clear all the settings back to factory default, and then I can set my options again and then do another transfer maybe. So the curl easy reset is just a way to avoid having to close it and create a new one if you just want to have it fresh, because it will allow all the caching to survive, which is a performance boost for you. That's really why you want to reuse handles, because we have a lot of caches internally. So if you reuse the handle, it'll run faster. The subsequent transfers will run faster. And I mentioned it already. Not everything. A lot of things in curl is provided or offered with and using callbacks. And callbacks, as you know, is just a function pointer that you hand over to curl, and curl will call that function at particular moments in time. And all the callback options in curl, they are called something that ends with the name function. And for all callbacks, there's a corresponding option called something ending with data. So for example, there's an option called curl opt write function. That's the write callback. It has a corresponding pointer called curl opt write data. And the data thing is just a pointer that you can set to whatever you want, because it's your pointer, but that pointer will be passed on to the callback. So it's a way for you to pass data from your application into the callback, or whatever you want to do. For example, you want to pass in some local data from your function into the callback that libcurl will call. I will show you, of course, in examples coming up. And then the callbacks will be called by libcurl when those things are needed that the callbacks are there for, if they are needed. But here's a little caveat here, an important thing. Do not call libcurl itself back again from within callbacks. So if libcurl calls a callback, then you're already within libcurl. So then don't call libcurl again back into libcurl again from within libcurl. It's usually it doesn't work. It will call return an error code. There are some documented exceptions, and you will know about it when you've read about the exceptions. So here's the example. You want, for example, you do a transfer, you have a write callback, and this is from the eyes of libcurl. When libcurl gets data from the remote, download from curl.se, it gets data, it wants to store it somewhere. So what does it do? It calls the write callback every time it gets data, tells the application, write this data somewhere, take care of it. I don't care how you decide. So data is then provided to the application using this callback. And you set the callback with this. I mentioned it already, curl opt write function. libcurl then wants to write data. And pretty much it means that it got data it wants to store. It could be a small amount, it could be a large amount. And this is the prototype for the callback. It's based on the fWrite function. That's why it looks like this. So it's a pointer to data, and it actually has a size and an nmemb, just because in my I'm not sure I should call it wisdom, but when I decided on this prototype back in the early 2000s, I decided it should look like and work like the f-right function, and the f-right function actually works like this. So the total size that is coming is actually a size multiplied by nmb. But then we've simplified it over the years because size was always 1. So you can pretty much ignore the size argument here and just go with nmem1, or multiply them with each other as you would with, okay, you get it. And then this user data pointer is that pointer that you set yourself with the curl of the right data option. It could be pointing to whatever you decide. libcurl doesn't care about it. It doesn't actually even know what's there. It just passes it on to your callback. You do whatever you want with it, and libcurl won't care, and it can't care. So here's an example. So you set up a right callback. Here's the beginning part of this example. Here's, in this case, I have a struct memory starting out from the top. It's just my custom struct. I just want to manage a pointer and a size. This is the data I want to receive. And then I write the callback itself. I call it write_cb, as CB for callback, and then I make sure that it uses the right prototype, as I mentioned. You can just copy and paste from the man page. And in my particular case, I make sure that I set that user pointer, the fourth argument, that's a pointer to one of those struct memories that I declared at the top here. So I just make sure that I have a struct memory variable called mem that I get a pointer to in the fourth argument. I check the size of the data that I'm receiving, and then I reallocate my memory that I'm keeping to store the received data into. So it's pretty inefficient, but this reallocates on every write then and expands the memory for every write. So it reallocates the allocated memory into the new size. That's the old size plus the new size plus 1, because it adds a zero terminate, null terminate thing there. So you reallocate, so I get bigger memory segment to store data in, and then below the reallocation there, I copy the new data into that new allocated memory area. I increase the size of the currently allocated memory, and I put in a null terminating byte at the end so that you can work with it as a C string properly. And of course, the setting up things, that's the top, and then here's the bottom thing, just the int main. As you can see, I declare the struct memory chunk there. I malloc a byte, and I said the total size is now 0 bytes. Set up everything. I set up a URL. I set the write function to the right callback. There's a write data that's actually passing in the pointer to my struct. And this example also actually set the user agent option. That's of course voluntary in this example. Why not? It's called agent dash, not dash, slash agent slash 1.22. I have no idea why I picked that version. Okay, and then perform the transfer. And of course, when this performs the transfer, it will connect to the server. It will ask for a download. It will get the resource. And for every chunk of data that libcurl receives, it will call the callback. And you don't know how many times it will be called. It might be called 1 time, or 22 times, or 33. Or if there's a problem, never, and it will just return an error instead. So you can't assume, and you also don't know exactly how big chunks you will get. You might get very small chunks or very big chunks. There's actually a maximum size to the chunks that you can figure out. It's once documented, but either way, you shouldn't assume that you will get small, large, big, and you can even get them both small and large, right, intermittently. And if you repeat the transfers many times, they might appear with different sizes every time. because it depends on network conditions and conditions in the server side and conditions on your network and conditions in your machine and so on. So don't assume about that. So that's how you do that was a simple blocking transfer, getting data into a single memory block in memory. We will get much more into many other options, but before I go through more options and everything, I want to just go back to the fact that I mentioned that this is the easy interface. It does synchronous file transfers, blocking ones, entire thing, and then it returns. But we also have a more complicated way, because in many times you don't want to have that just one transfers in a blocking way, because maybe you want to do other things at the same time. Maybe you want to do many transfers at the same time without having to fall back to doing many threads or whatever. So then we have the multi-interface. The multi-handle is then a new handle, another handle than the easy handle. It's a multi-handle. It's a handle to hold many easy handles. It's a super handle. You can add many easy handles. And one easy handle is for one transfer, right? So if you add more easy handles, that's for more transfers. So you can add many transfers, many easy handles to a multi-handle. And when you have many transfers added to a multi-handle, you can do all of those transfers in parallel, simultaneously, and in a non-blocking manner. So basically, you can have a single-threaded application doing a lot of parallel transfers. And with the multi-handle, you can also have it wait for your own sockets or file descriptors or everything in parallel to the ones that libcurl is doing. So you can pretty much do a lot of different things at the same time without using threads. And of course, you can add transfers and remove transfers at any point in time while the transfers are going. So you don't have to actually set up all of them at once first. You can actually start with one transfer, then add a second and a third, and remove the first, and add the fourth, and remove the second, blah, 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 according to your needs and wishes, of course, and whatever you want to do. And you do this by creating a multi-handle. So curl multi-init in the same fashion. You recognize the pattern here. It looks very similar to how to create an easy handle. You just create a multi-handle. Curl multi-init returns a new multi-handle. The multi-handle, of course, is just a handle. And then you add, I want to add easy handles to this multi-handle. Then you add them with curl multi-add handle. Of course, however many transfers you want. Maybe one, maybe three, or something like that. And when you've done your entire transfer thing and you're done, you clean up. Yeah, also you can remove easy handles again, of course. Maybe when the transfer is done, maybe before it was done, because you just let's give up. And when you're done, you do a cleanup. But okay, that wasn't mentioned there. So basically, you add a bunch of easy handles to your multi-handle, so you can do a lot of them in parallel. So when you want to drive them, let's do all my transfers. You drive them with this function. So similar to the curl easy perform, there's a curl multi perform that then performs transfer for a multi-handle. Transfers really, or any, could be one, could be many. And this is a little bit different than the easy one, because this will only drive them as far as it can without blocking. So in this case, it will, do a small amount of work and then return, because if it couldn't do anything more without blocking, so then it returns. So then your application then waits until there is more work to do, and there's helper functions that lets your application know when there is more work to do. The easiest one is curl multi-poll. Basically, wait until libcurl has something to do. Basically, if there's an incoming activity on a socket that libcurl is using, then we can continue. If there's no traffic, nothing happens, we can just wait. Curl multi-poll can then also wait for your application's file descriptors or sockets and so on, or you can do something else. And then you can also check if there's any activity, if any of the transfers are done, right? If you set up, I'm going to do 200 transfers, you want to know when one of those transfers are complete, and you check that with this function, curl multi-info read. And then you can move on, and if there while there are if there's still transfers going, I mean, you did a perform, you waited for something to happen. If something happened, or maybe you check if or have any transfers completed, but there might still be transfers ongoing, then you just continue that journey. So this can go on forever, right? So whenever a transfer is done, you remove it from the multi-handle, but you can always add a new transfer, right? So you could basically just keep adding transfers. You don't ever have to end the curl multi-perform loop. Could just, well, as long as it has transfers to perform, it will perform them. Or whatever you're done, you're done. So this is up to you and your logic here for your application. In the multi-internals, right, I just wanted to mention that the easy interface I mentioned before is actually just a wrapper around the multi-interface. So actually everything internally is a multi-interface. The good part about that is when you ever contribute any code to libcurl, everything is actually treated as multi internally. So you can think of everything as non-blocking multi-interface internally. So I wanted to, I mentioned that we have this function. So since curl multi-perform drives a lot of parallel transfers, right? It might be, say, 22 transfers in parallel, and curl multi-perform drives them all. So it can't return any information about a single, I mean, if curl multi-perform runs, right, and it can't return information about individual transfers because there are 22 transfers. That's why we have curl multi-info read. It basically gets a queue with information about individual transfers. So if you call that, and it's a really fast call in case nothing happens, it just basically just calls a queue. So if any transfer has completed, it will return info about that completed transfer. So, oh, transfer 17 has ended. It ended with return code 0. Everything was fine. And then, so continue. And the next time you might call that function, it says, oh, well, and the next, and you just call this function multiple times, and it will return information about transfers that have completed, or null if nothing has completed. So that's basically how you do. And for every completed transfer, you get the handle to that, easy handle to that transfer, and then a return code for that particular transfer. So you know exactly which transfer ended, how did it end. And the curl multi-info read function returns a pointer to a struct that looks like this that I'm showing here on the slide. Basically, it returns a message that says, because originally I anticipated that it could return a number of different messages. So there's actually still only one message type that can be returned, and that is transfer completed one. And then it returns an easy handle, and it returns a result. So, and when you've done all your 22 transfers and you don't want to do any more, or maybe you added 3 more and then 25 are completed, then you're done and you don't want to do any more transfers, you can call curl multi-cleanup. That's, of course, then it kills the multi-handle and free all related resources. You're supposed to remove all the easy handles from it first, so that you do the same thing but in the reversed order. So if you added easy handles before, you remove them and then you clean everything up. Because multi-cleanup, it doesn't free the easy handles. So you have to also do the curl easy cleanup per easy handle, as I mentioned before. So I talk a lot about using APIs, and I understand that talking about it is not the same thing as showing and showing code. So here's an example. First, we said this is a little example. It's going to do two parallel transfers. They're both HTTPS. For some reason, they could be different protocols because the API is used exact same way, no matter which protocol. I mean, one of them could have been FTP or IMAP. It doesn't matter for the example, really. But it creates, you can see here, two easy handles, easy and easy2. And then it sets the URL for both of them, for the easy one and then for the easy2 one. First is https://example.com, and the other one is https://curl.se. So it has two easy handles with options set, and then it creates the multi-handle, returns in a variable called multi, and it adds the two easy handles to the multi-handle with curl multi-add handle, right? I'm going to do the transfer. I'm going to transfer those two transfers using, and then we do the actual transfer. Starting from the top here, while there's still transfers going, call multi-perform. And as you can see, at the second argument to the curl multi-perform function, there's a pointer to the still variable. It will actually return the number of transfers that are still active, still alive, still ongoing. So that's why the next line is a condition there. If there are still transfers ongoing, then wait for a while for something to happen so that we can continue later. I mean, continue when something happens. Maybe there's incoming data on a socket, or maybe it reaches a timeout. And the 1000 there, that is the fourth argument to curl multi-poll, is just a timeout, or timeout in 1000 milliseconds, and then we loop anyway. Basically, you can do that to have a progress meter or do something else periodically. And then later here, we check the curl multi-info read, which then checks the queue. Did anything happen for any transfer? And it will return an information about when the curl message done is set, a transfer has completed. And in this case, look at that. It's a little bit broken there because the last line is hard to read. Anyway, so this then loops, so it goes back. So as long as there are living or active transfers, this will continue to loop. So it will stop the loop when all the transfers have completed. There's no more ongoing ones, which in this example are two transfers. So when both are completed, the loop ends. And then we tear down everything. We remove the easy handles again from the multi-handle. We clear up the multi-handle with curl multi-cleanup, and we clean up the easy handles. Bam, bam, and then we're done. So then we did two transfers in parallel. Both of them, of course, very basic here because both of them sent everything to standard out. So everything would be mixed from both sources, possibly. So not an ideal application here, but small and simple. And I think you get the gist of it. And I mentioned it already before, but there are a lot of caches involved in curl. So caches in ways to store data to make it faster when we do things again, or and when we use the easy handle and easy interface, as we do curl easy perform with an easy handle, all of these caches are kept and stored associated with the easy handle. So as you can see, the little buckets I show you at the bottom of the slide here, the DNS cache, that's how you store names to IP addresses, right? That's a cache. So it'll when it wants to look up the same name again within a short period of time, it can just use the same IP as it just got seconds ago. There's a connection pool. I'll talk about that in a few seconds. So it keeps connections alive a little bit after it has used them. So make sure that if you use the same host name again, it can go much faster. There's a session ID cache, which makes curl do faster TLS handshakes in subsequent connections to the same host again. And it also stores the CA store in memory to make sure that it doesn't have to reparse it if you use it again within a certain amount of time, and so on. And there's cookies, old service data, and HTTPS data. They are shown in red here because they are per single handle, even when you add them to the multi-handle. Because mostly the green ones on the left side, those caches are kept in the multi-handle. So they are automatically shared between all the parallel transfers if you do parallel transfers by default. to complicate things even further, as if you needed it, there's also this curl multi-socket action, which is a sort of a variation of the curl multi interface. You know, how to drive a lot of transfers in parallel, because this is how to drive a lot of transfers in parallel, the event-based version. And event-based pretty much means that you trigger events based on changes on the socket situation, right? And usually this is, you drive this with an event-based library or system. And this is really the way you want to do. If you go, let's say you do an application, and if you go beyond and above, like say a few hundred transfers, because then you really need to think about, because using select or poll, the normal wait for a lot of things happening in curl, those solutions turn really slow once you go beyond a certain amount of transfers or sockets. I mean, you don't see the sockets, but curl uses them. So if you do like a few hundred transfers in parallel with normal curl multi perform, you will see that they might not be as fast as they can be. Then you want to go to the curl multi-socket action, because it's much better to deal with a huge amount of parallel transfers. And if you go with this, usually then you have a event library like libevent or libev or libuv. There are several different event libraries. Some of them they usually tend to be a little bit different on different platforms. But anyway, when you use one of those event libraries, that's usually you interface with them and you say, I have this socket and I want to wait for that activity on that socket. And when you use this libcurl API, libcurl will tell you what sockets to wait for and what activity to wait for on that socket. And it will tell you about what kind of timeout timer that we want to expire, and I mean at what time it should expire, and then you should tell libcurl about it. So basically, you use that event library and you ask libcurl to tell you about sockets and timeouts. And when those sockets get activity or the timeouts expire, you tell libcurl about it with curl multi-socket action. That's basically how you do it. And that's how it scales really well up to, well, I've had users done up to 40,000-50,000 of parallel transfers using this. Takes a little bit of tweaking to do that on a normal system, but it's possible. And I'm not going to get into a lot of detail exactly how to use this, because doing event-based programming is more complicated than normal linear sort of programming, and it's harder to get everything right. And I'm not, this is not this time for me to get into all of those details, but read up about it. There are examples, and if you know event-based, you see how this maps to your event library. It's really cool. Okay, we're getting somewhere. It says out of 88 slides. I'm not sure there actually are 88, but maybe they are. If they are, we are 20 slides off, and we're half an hour left roughly. I don't think I'm going to make it within 2 hours, but okay. So I showed you some basics of how to do basic easy transfers and basic multi transfers. And I'm going to sort of, that's how you do the basic transfers. And now I'm going to go back and go into more details about how to tweak things about the particular transfers. And we're just going to start about how to set up things when you want to do applications doing libcurl transfers. For example, you want to make sure that you get verbose information. And verbose information you can get in several ways when you work with curl, libcurl. For example, you want to make sure that you set this option. This is an option that tells libcurl, here's a buffer to write errors into if you run into any. Which is, you know, I showed you how it always returns an error code. So you know, you're sure it's returned 27 when something bad happened, and then you can figure out what error 27 means because it's documented and there's a function that can convert it for you. But sometimes libcurl can actually tell you about more details about exactly the situation that happened when you got return code 27. And the only way for you to get those details might be to provide that error buffer, because then libcurl can provide you more information, more detailed information about that particular reason why you got 27 in this particular instance. So you really want to do this, at least for development and figuring things out. And the curl up verbose is really key to understanding what curl is doing. So if you set this one to 1, you enable it, you get a lot verbose information sent to standard error about what curl is doing, thinking, sending, and receiving to help you understand what's going on. And again, in particular, when things are not working the way you think they should, setting this is a perfect way to get a lot of more data for you to understand, oh, now I see this is what's happening. Maybe I should tweak this and that. And you basically just do this. In this example, you're going to see it starts out with an easy init, and then it has a buffer with a curl error size, and it needs to be at least this big, the error buffers you provide to curl. And then you provide the buffer to curl with the curl opt error buffer. You set the verbose level with curl opt verbose, or you enable verbose. You set it to 1. It has to be 1. Well, you can switch off with 0. There are no other values that are supported for anything. The other ones are undefined, so maybe they will be used for something in the future. And it sets the URL. So this then makes the transfer with verbose enabled, and it has passed on a buffer for errors in case there's an error. And I'm showing you, in this case, this little code here then says, if an error is returned, check if it got data in the error buffer, then output that. And if no error was provided in the error buffer, show the reason for the error code that curl easy through error contains for it. The line there that says curl up verbose, you can see that it says 1 and a capital L, and that's just C style. For that capital L means that's a long type. So I could also just typecast it as a long with parentheses, long parentheses. So just that goes back to the thing that the compiler doesn't really know what kind of type that it's supposed to pass in there. So if you don't explicitly say that it's a long, the compiler might think it's an int, and that's wrong here because it's supposed to be a long. So that's why we enforce it as a long with the with the 1 and a capital L. You will see this in a lot of examples and code. I try to emphasize this on all my examples. Maybe I forgot it sometimes, but you will see it all the time. So, and another way to help you out with if the error buffer and verbose is not enough for you, then there's this extra option called debug function. It's pretty much a way to, instead of sending everything to standard error, because that's might be inconvenient for you, send it all to a function that you provide. And there's also this recent addition to the family called curl global trace. Says, I want to get extra information about these particular details that's happening inside curl. And I'll show you. You can also get information, and in particular within the debug functions, about what transfer is happening and what connection is it does it relate to. So whatever the information you get in the debug function, it could be related to a particular transfer and a particular connection. And it works like this. In this case, it's a debug function callback. So it's called by curl when it wants to deliver debug information. That's probably quite often. And as you can see at the top here, it's a prototype for handling. It's a callback that will get called, a curl handle in the info type and data and the size and the user pointer. And it can do whatever it wants with the information, right? And in this case, it doesn't actually do anything. I just showed you the skeleton of how it could be started. There's actually a pretty good example on the curl site that you can get. I think it's called just debug.c, that actually shows a complete example with with the details and blurring things out in a hex output style if you want to. And then if you show here the setups later than the bottom half of this example, you can see that it sets the debug function and it sets the debug data. And again, the debug data then, as a reminder, passes on the pointer that becomes the user pointer in the callback. So in this case, it provides a pointer to the config struct. So that provides that pointer into the callback. And again, the verbose, it has this one capital L thing. Make sure that it's long set to 1 to enable verbose. And you get more information sent to your application. Maybe you want to store it in a log. Maybe you just want to have it, keep it around in case you have problems or whatever. The debug function also gets all incoming and outgoing data, so it can actually log and keep track of everything very, very detailed. And in this case, also here's how it uses the global trace config thing. It says, oh, I want to get all the details about all protocols that it can possibly provide data for. And this will get you even more data into the debug callback. You should read up about, read the man page for curl global trace, because you can select, you can have, I just want the HTTP2 details, or just the HTTP3 details, or just the TLS details. There's ways to configure exactly that. And again, you probably want to disable that exactly for what you want to debug. Maybe not go with all. At least when you go with all, you might get a lot of data. And as I mentioned, you can also extract the transfer and the connection ID. Pretty much, I guess that's a way for you, if you get a lot of different debug information, to correlate which of the different, I mean, how do they belong to each other? So you know that it's the same connection, same transfer, then you know it's related. Because if you do hundreds and hundreds of parallel transfers, you might get quite a lot of debug information that could be, you know, for different transfers, different connections. It might be difficult to correlate them with each other sometimes, unless you ask libcurl for details about it. There's also a way for you to figure out which libcurl version you're using, and by then also going with that, what kind of stuff that your particular libcurl version that you run right now, what does it support? What version is it? What protocols does it support? What features does it support? And I'm just wanted to show you that in this little thing here. In this case, it shows an example here then that calls in first global init, and then it calls, and it shows the curl version. Curl version is a simple function, just returns a pointer to the version string, not very practical. And then it has the curl version info that returns a pointer to a struct with a lot of data about the curl. And in this little example, if you run it, it'll show this output. And in this output, I just highlighted every other line to make it slightly easier to show. But this is, if you compile the example on the right and run it, you will get the output as I show you on the left. So as you can see, it gets information about the curl version there, libcurl, and all its particular components and versions of those. The version number, and you can get the version number in a numerical way, and you can extract the parts of it. You get all the features as named features, and you get all the protocols as named protocols. They're actually URI schemes that are support for URLs. So, and you can actually get quite a lot more information. You get a lot more detailed information from that struct. So whatever you want to know about the particular libcurl you run right now, the binary thing your application is using, this is the function for you. And to help you write your applications and know what you can use when, right? It's, as I said, 252 releases of curl. Maybe 200 of them have been different libcurl versions. I haven't really counted, but there's a lot of new things added over time, right? So how do you know when you can use what in what version? Then we provide this fancy table called symbols in versions, and it exists on this URL that I show you here on the screen, and it basically looks like this. The symbol on the left, when was it added to libcurl? That's the version number, and from when one is deprecated, and actually in some rare instances, which was the last version that supported this thing. And you can see that I think the list contains now 1,400 symbols or something. So it's a lot of them. So if you're ever curious, is this particular symbol supported in this particular version? You can check it out. Right. And so when you do a transfer, a significant part or important part of doing a transfer is, of course, connecting to that server you're going to do the transfer with, right? So then you need to resolve your host name to a set of IP addresses. You want to do happy eyeballs being connecting to both the IPv4 version and the IPv6 version at the same time, and getting with picking the one that completes first. And you want to select, maybe I just want to pick one of those IP versions, or maybe not the other, or whatever. And at the same time, curl will help you to do persistent connections so that it will keep using the same connection even when you do repeated transfers. And basically it works like this. And I alluded to that before when I talked about the connection pool, that you have a client that want to talk first, you want to talk to maybe example.com, set up a connection there. And afterwards, when it has completed that transfer, it will store that in the connection pool. And remember, I have a connection to https://example.com port 443. Keep it there. And then we set up another connection, right, to maybe curl.se. We do a separate second connection. Oh, that's a separate connection. It will do the transfer to curl.se. Everything works. And then when that is complete, it stores that one as well. Both of them are now live connection stored in the connection pool. So they're still alive and well. And then when the client wants to do a third transfer, and this time back to the same host that it started with, example.com, you want to do that, and it finds that it actually has it in the pool, it will pick it up from the pool instead of creating a new one. So just reuse that. It's in the pool. We don't have to set it up again. We can just reuse it. And number three can then reuse the connection that it has already in the pool. And that's really the key to do really fast subsequent transfers. So if you have a loop and you want to do 200 transfers to your same host name, it'll automatically then reuse the same connection as long as it can, as long as the server allows it, as long as everything works, it'll just keep reusing the same connection thanks to this connection pool, sometimes called the connection cache. And that's really cool. And they are stored there if they are still alive, right? So if they're not alive, if someone closed them, or if someone told us to close them, they won't be stored there, right? And it has a finite number of entries. Basically, you can set the number, curl opt max connects. So it's fairly low generally to begin with, because it's typically, you don't want to have them there for a very long time anyway, because they're less likely to actually work if they stick around there for a long time. So maybe you don't need more than a few. They're also only kept around for a certain amount of seconds, called curl up max hcon. So that's set to 118 by default. So basically, after 2 minutes, they won't be reused anymore, because the likeliness that they will still work is so low. So basically, it's not practical. But you can raise the limit if you think that's good for you. Right, I wanted to also just emphasize that the connection reuse is done per name, then not per IP address. So if you do a connection to example.com, example.com will of course be resolved to a set of IP addresses and connected to an IP address when you do the connection. But when it's stored in the connection pool, it is remembered by name. So when you do a second connection to example.com, it will be reused. And then the second connection will just then, of course, use the same IP as the previous connection, because that connection is still there. But it won't resolve the host name the second time, because that would just be slow and take a long time. So it sort of skips the resolving part when it can reuse a connection. no point in resolving the name. That just go with the existing connection. And this works for all supported protocols as long as the protocol itself can do persistent connections like this. And of course, exactly figuring out which connection you can reuse and cannot reuse is a bit of a tricky thing. So it has a number of conditions and extra requirements. So sometimes you will see that it won't reuse a connection that you thought that it might be otherwise, but it's slightly difficult logical thing there. You can say that this new transfer that I'm doing, don't try to reuse an old connection by setting this option, fresh connect. Maybe you have a reason for doing that. Maybe you know something that, I want this to be a new one. You can actually also say, this particular transfer that I'm doing, this connection should not be reused after this transfer is done. So forcibly close this afterwards, which also, again, you might know something that we don't, but it's really bad idea typically because it makes it for much worse performance if you do this. And of course, there's this tricky other little thing that you might want to do. You might want to add keep alive, because that's a TCP feature that just makes the TCP connection do some extra ping pong talks so that it is likely to keep the connection better alive. It won't be idle for very long then. So pretty much when you set up a connection, you can also, what's fun is this, you can do fun name tricks. For example, you can pre-populate the DNS cache by providing a name to an IP address lookup. In this case, for example, here, this little example here, it provides first example.com on port 443 should resolve to this IP address 127.0.0.1, that being localhost. And it also provides another lookup for the www.example port 443 to the same IP address. Basically, it allows curl to sort of, you pre-populate the DNS cache. So when you use, as this example uses the example.com hostname, it will find that we have already populated the DNS cache, so it won't resolve the hostname using normal means, but it will find our sort of quote-unquote fake entry and use that instead. And that's just a way for you, for example, convenient way to work out when you have a experimental thing in your lab or development thing, and you want to use real URL, but you don't want it to connect to the real server, so you can redirect it somewhere else. And this is a fancy way to do that. And you can also, instead of redirecting from a host name to a particular IP address, you can also internally rewrite one host name port number to another host name port number. So in this case, for example, this redirects your curl.se port 443 to example.com port 443. So instead of connecting to, even though the URL says curl.se, it will internally change that name to example.com, resolve that, and connect to that server instead. Again, fancy if you want to do your experimental development things, or redirect whatever. Maybe, yes, it's up to you. It's really convenient sometimes if you want to go to, in this case, for example, if you have a number of servers being load balancers for a single site and you want to go to one particular of those sites, so maybe you want to go to one dedicated host name and still use the generic one in the URL. Maybe just be aware that when you're connecting to the wrong host, sometimes you will have a problem with the name in the TLS certificate when you verify. That's why this example disables the SSL verify host option here, because maybe otherwise you will get a certificate error, or maybe not. It depends on your situation. I really cannot tell, but might be important to just remember that and keep that in mind. But and if you do fun things, if you use CARES as a backend for name resolving, which typically people don't, but some do. And if you do that, you have more options to also play around with the name resolving part, because then your name to IP thing, you can set things like a dedicated DNS server for your particular transfer. So instead of using the default name servers, you said, here are my name servers to use for this particular transfer. Pretty fancy, but of course it requires you to know this, and it's a niche setup. And it requires your libcurl to be built with CARES, but still. Cool. Okay, and why not? In a modern computer today, you have a lot of different network interfaces. Maybe you have them connected to different networks, different setups somehow. And sometimes you want to select that to go, your traffic should use one particular network interface and not one of the others. And then you can tell libcurl to use, I want to use this particular network interface with the curl up interface option. Easily specified like this. It's a string, so you just curl up the interface and the name of the interface. And this is a interface name on your machine that you're using right now. In my case, this ENP3S0 is actually an interface name on my local development machine. The names will be different on your machines. They have to actually exist. They have to actually work. If you, 1 second, I think a little bit loud here. There, okay. I was talking about the network interface, right? So, and in this case, you set the network interface name as a string. You can actually also provide it as a host name and an IP address. Yeah, but then you have to, it's a little bit complicated because it still has to be it has to end up the IP address of one of the interfaces that you have, right? You cannot just invent an IP address to use as a source address. It has to actually be the IP address of a network interface that you are using. So you can't provide it as an IP address if you want to. A little bit complicated, but it's useful when you need it. Another niche thing is that you can, instead of then just binding your local end to a particular IP address, you can ask libcurl to use a particular local port number or local port number range. I think this in the past I've heard about people mostly using this. For example, when you have maybe you have a firewall that restricts all your outgoing connections has to use your local ports within a particular port range. Otherwise, we know that it's a malicious thing, so we will not allow it and something like that. But anyway, curl then has these options to set the local port and the local port range. Basically, try in this example, try port to 20,000 and try all the other port numbers up to 10 numbers following, because it's a finite resource, right? Maybe someone else is already using port to 20,000, then we can't use it. So then we can try the next one and the next one. And in this case, try 10 different ports until it fails. It is, of course, more risky that you will get a failure because trying to use a specific dedicated local port is going to fail more times than not limiting your connection to a particular port range. And I got the question here, if I mentioned the interfaces, the network interfaces, of course, you can use virtual network interfaces too. You can use whatever network interface, as long as it's a network interface in the eyes of the TCP stack. This one, going back here to the network interface. So the network interface is actually what is provided for the TCP stack. So a virtual network interface is also a network interface to the TCP stack. So it doesn't matter if it's physical, real. I mean, it's the TCP stack and the curl, they're all just interfaces, so they will work. Local port ranges, fun. And as I mentioned before, then TCP keep alive is a way to, when you set up a TCP connection between you and some other site, a TCP connection doesn't have any traffic. Nothing happens over the network if nothing is transferred. Pretty much, there's if you're done with your transfer, or if the transfer is slow and hold up for some reason and nothing is being transferred, then it's really nothing happening. So it can then be completely silent over long periods of time if things or conditions are there. And having completely silent connections, that leads to things like them being disconnect firewalls and servers, and then we'll disconnect things. But nothing is happening here. We'll just kill it. And the good part of a TCP connection being possible, I mean, having the possibility of being completely silent, is that you can actually, a completely silent TCP connection, you can actually, rip the cable out and put it back, and nobody will know, because there was no traffic there. So no one knew that it was actually disconnected for a while, because there was no reason to know that. But that also means that, sure, if it gets disconnected, you won't know that it gets disconnected until you actually want to send traffic over it. So that's also a reason why you want to go with enable keep alive, because it will then help you detect disconnects and stuff like that. So usually, maybe having a keep alive, I mean, for many situations you want it because it helps you detect things better. In some other situations you don't want it. So what do you want? Anyway, curl supports TCP view to set TCP keep alive. So then curl will use TCP keep alive on the connections that it creates. And basically, you can then set different interval timers for when to send the keep alive and so on. As I showed you here on this example, this actually has one option that is a Boolean that says on off, and then it has two other pretty much how long to wait until it's considered idle, when to start sending them, and then how the interval between sending those probes. And if that's not enough, sometimes sometimes they say that IPv6 is a new thing we should use. I'm kidding. It's been around for pretty much I think longer than curl has, but still, IPv4 is maybe the dominant IP protocol version, but they both exist, they are both used, and maybe you want to use one or the other. Curl will by default try to use both, and it will happily use both, and it will try to use both. As long as your local end supports it, the server supports it, it will try both. And it, as I mentioned before, it uses the happy eyeballs approach. Happy eyeballs means that it first starts a connect attempt with one of the protocols, and then it starts the second, just slightly behind. So they go both in parallel, and the one that completes first will be used, and the other one will be thrown away. And typically we start the IPv6 one slightly before the IPv4 one. So if both are supported, it should prioritize the IPv6 one. But if the IPv6 one fails or is slow for some reason, it will go with the IPv4 one. And also if the IPv6 doesn't work for some reason, it will also go with the IPv4 one. And you can change then if you don't want to do the happy eyeballs. If you want to go with one of them, you can just tell curl to use the one I know, like this, and in this using the curl opt IP resolve option, say I want it to use v6 only, and then it'll try to do the connection using IPv6 only, and it will fail if it can't use IPv6. Maybe you want that, maybe you don't want that. You can use it. And getting to the end of the part one, I wanted to mention then, of course, that authentication is a pretty big part when it comes to transfers in general. Authentication being you have some kind of credentials showing that you are allowed to access the resource you want to get or put. And most of the protocols curl supports offer authentication in one way or another, and many of them have more than one type. So basically you can select different types of authentication. And this is a really big topic, and I'm not going to explain a lot of details about it because it's not a niche thing, but it's such a wide topic. So whoever you are, I'm probably not going to be able to cover your particular needs. So if you want to read up and you want to use more authentication, read up on these options, because typically authentication involves setting a username and a password by default, at least. And typically curl has a default method that it does authentication. If you set username and password and you use a URL, it will use authentication and will try to use the correct authentication, but maybe you need some other options to tell which kind of authentication to use. Sometimes you need something more as well. if you talk with a proxy, it has an own set of additional options. So you can use authentication with the remote server, and you can use authentication with your proxy, and they are independent, right? So you can, that's a double set of options. And the proxy then can also use different methods, because there could end up a lot of different options and combinations. And to make matters slightly worse, maybe, for HTTP, there's, I mean, we are all used to logging into things and providing username and password to things on the web, right? But many times these days, that's not used with HTTP authentication on the protocol level HTTP. It's usually these days done by an HTTP post and keeping state in a cookie. So that's not actually authentication in a protocol level, but it's authentication on a application level. So for the cookie adventures, we're going to get into that deeply in part 2. So I will save that for Monday. But if you just wanted to see the basic stuff, how to access a resource, providing your credentials, like on curl.se, if it would be authentication, I mean, if it would require a credential, you would set it like this: username and password, Clark and Kent, and it would just magically use that. In this case, when you use HTTP, the default method would be basic. It's called basic. It's a pretty naive implementation of to do it, but yeah, that's how you provide the default way to do authenticated transfers. And with this, you can also then provide authentication information in a file called netrc. The .netrc is an ancient standard for providing username and passwords for particular machines, originally done to help for FTP. I think this particular file format has traces back to early 1970s, so it has actually existed for over 50 years. It's a pretty weakly defined syntax, but libcurl support it, and you can provide credentials in this file like that, and you can, it's a default in home on a user, not user, in a Unix system, it's a user's home directory. So in Linux, it exists there. And if you want to tell libcurl to use it, you say, hey, I want to use the curl-up netrc, and you can tell it to have netrc optional, or you can actually call it, make it mandatory as well. I don't remember exactly what the name is then. And then you can provide a custom file name instead of using the default. Here's a particular file to consider to be a netrc file, and then access whatever. And the netrc file then ideally then of course provides credentials for that particular host name you're accessing, because a netrc file can provide credentials for a lot of different machines in a single file. It details name, password, and machine. So it could be a huge amount of them. So that's a traditional way to provide authentication. But of course, if you provide name and password in a file, make sure that no one else than you can read it, or at least only the ones you know or is supposed to be able to read it can read it. So it's a bit of a sensitive thing, right? It's again back to the question about password security and everything, a complicated thing. Right. And as I mentioned before, right, all the curl is interface functions, they return this variable type. It's a numerical thing called curl code. And we have the similar pattern for other APIs. The multi-interface return curl M code. The share interface that I haven't talked about today, I will talk about it on Monday. It returns also the same thing in the URL interface. You can see the pattern here. They're all type deft enums. So basically they return a number. 0 is okay. Non-zero is an error. They all have str error functions that can return a string that is an English explanatory phrase for that particular number. So you will, you can determine if you got that, I got a 7 back, what what the 7 mean, because the 7 has a name in code, so you can use the name from the header file, but maybe you want to provide it to a user or in a log, and then you can convert it to a string using the stir error functions. But again, 0 is always success, non-zero is an error, always for all these error codes. All the errors, of course, in detail are provided in the libcurl errors man page. As I mentioned, I think already, we have a lot of man pages. So read up in the man pages. If there's ever any doubt, read the man page. And with this, we have reached this point in the presentation, which is the intermission. So I am at 2 hours, 9 minutes, something, maybe 2 hours and 5 minutes. So with this, I am happy to say that you have survived part 1 of the Mastering libcurl video. In the next part, there's going to be more getting into the details about more fun stuff with transfers, more share API, URL API, header API, and things going even beyond just doing transfers, but also managing the data in different ways. So this recording will be made available after the fact. I will make the slides available as well, and I will everything will be available to everyone. So in case you miss out, you don't find them, just get in contact with us, and we make sure that you get the links to everything, all the data. And again, on Monday, the same time as I did today, I will start part 2, roughly the same length. So if there is anyone with any more questions, so fire them off right now. I don't see any questions right now, so I think I'm good. So anyway, this was fun. Thank you for attending. I'm going to do the same sort of double setup with Zoom and Twitch on Monday. So you choose whichever you want to do. The Zoom one has the kind of a edge that it has a pretty good Q&A button that I've sort of been able to read and follow the questions live. But the chat in Twitch also works very good for that. So yeah, I think for me it worked out really good. I've already stopped the recording now, so now I'm blabbing on. So I think I'm done for now. So thank you for joining this. It was fun. I think it's good to get this in a video. I think it'll help people going forward.